Okay, so we are going to draw a mesh diagram which would assist us to find our forward pass, the backward pass, and the slack, or the entire project duration. And so don't forget this. I decided not to claim this one because this is really going to inform us a lot. So let me write here the rule, because this is the rule. I mean, we can't do away without it. So this is going to at least help us with the forward pass calculation and the backward pass calculation. So we are just going to repeat this same diagram here. But then for every activity, we are going to have this drawing, these 6 boxes for each of the activities. And so for activity A, which is activity A, activity A. So this is activity A. Activity A. So activity A has duration of 2 weeks, which means it's taking us 2 weeks. It will take us 2 weeks for us to finish activity A. This is 2 weeks. Then we go to activity B. I told you we are drawing the same diagram. And so from here, we go to activity B. Activity B, and then we get our 6 boxes nicely drawn here. Activity B, and activity B has 4 weeks, so 4. Very good, 4. Then we have activity C, which also comes here. Please forgive me for my diagram. It's not drawn to scale, so it's going to be like this. So activity C, and activity C is going to take us 3 weeks. Then we come to activity D. Activity D, and activity D is going to take us 5 weeks. Then we have activity activity E, activity E, activity E, and activity E will take us 2 weeks. Then we have activity F. Activity F, and that is also taking us 5. So this is drawn nicely, and this is nicely drawn. And so we are going to start with our forward pass. And we say our forward pass is equal to ES plus duration. And we say our ES is the earliest start time. Therefore, activity A is our start time, or is the start activity for the entire project. And so activity A would always have the starting activity would always have 0 ES, which is the earliest start time, would always be 0. And we say that our forward pass is ES plus duration, which will give us our forward pass, right? So 0 plus 2 is 2 here. So activity A has 0 start time, or earliest start 0. It has duration of 2 weeks, and so 0 plus 2 is going to give us our forward pass, which is our EF, the earliest finish of 2. Now, for the explanation of this table, I told you that A is the predecessor of project B, which means that we can only start project B when we are done with project A. And for this diagram, project A is going to take us 2 weeks to finish. That is the earliest finish time. The earliest finish time of project A is 2 weeks. And so if project B can only start when project A is completed, and project A is going to be completed in 2 weeks' time, then we can say that we can only start project B in 2 weeks. That's the same 2 weeks after project A is completed. And so for any activity, the earliest finish time of the predecessor is the earliest start time of that current activity. And so for activity B, which has A as predecessor, the earliest start time, the earliest time we can start activity B is the earliest finish time for activity A. That's why you have 2 here. So very easy. So we are going to use this same explanation to calculate for all very quickly. And so 2 plus 4 is 6 here. Then we come here. C also has A as the predecessor. And so the earliest finish time for A is going to be the same for the earliest start time for project C. So 2 here. So 2 plus 3 is going to give us 5. Now let's take note of something here. For project D, we have project C and project B being the predecessor of one activity. So activity C and activity B being the predecessor of one activity, which is D. The table says that D has predecessor B and C. Now, per the understanding of predecessor, we know that a project can only start after when the predecessor is completed. So if D is waiting for project B and C to complete, and project C is going to complete in 5 weeks time, and project B is going to complete in 6 weeks time, then it is appropriate, or it is right, for us to say that project D must wait for project B first, because project B has the longest finish time here. If project C finishes in 5 weeks time, project B is still ongoing, because project B is completing in 6 weeks time. Meanwhile, project D is waiting for both of them to finish before we can start project D. Therefore, we have to use project B's earliest finish time, or EF, because that will finish after this one, after activity C. So one thing we have to bear in mind is that when we are working on the forward pass, and then you have multiple activities being the predecessor of one activity, then you use the highest value, the highest EF of those 2 activities as the earliest start time for the next activity. So the next activity is D. And mind you, E is not connected to B and C. Activity E is only connected to B. But now we are talking about D, which is connected with B and C. Activity D is actually waiting for activity C and B to complete. And B is finished, activity C will finish in 5 weeks time. Activity B is finishing in 6 weeks time. So activity C can finish, but then until B finishes, we can start D. So it is very reasonable that we use 6 here. 6 plus 5 is 11. Here, activity is only connected to activity B. So we use 6 here. 6 plus 2, we have 8. Now there's another double activities being predecessor of one activity. So activity E and D are the predecessor of activity F. And we are going to use the same explanation here. And so I'll choose the EF of activity D to be the ES of activity F. So this is it. Now we have to calculate the EF of activity F, and so it gives us 11 plus 5 is 16. And so you could see that the forward pass, which we said is EF, the earliest finish time that we calculated with the path, the three path that we identified. Now we realize that it is indeed the 16, that is the 16 weeks that is actually going to take the whole project to finish. So the 16 weeks is the entire project's duration. Now, whether the EF and the ES and the LF, which is the earliest finish time of a project and then the late finish time of the project, must all be the same, because at the end of the day, whether you finished early or you finished late, you are finished. Whether you finished early or you finished late, the point is that we have finished. And so at this point of F, we have completed the project, and so we can put 16 here. Now we go back to our backwards pass. So let me clean this side and then write the backwards pass. If you remember, I said the backwards pass is equal to the late finish minus the duration. And so the forward pass, you could see that we are moving towards the right side of the project. But then with the backwards pass, we are going to move towards the left side of the project, the opposite side. And so when we were working on the forward pass, we realized that if we get two projects linking to two activities linking to one activity, or if one activity is waiting for two activities, the predecessors, to both of them complete before it can start, we use the highest EF of those two predecessors to be the ES, which is the earliest start time for the particular activity. But when we are coming backwards, then we are not going to use the highest values, but we are going to use the smallest values. And then when we're working on the forward pass, we're adding. Now for backwards parts, we are going to be subtracting. And so I'm going to do it very quickly. Now 16 minus 5 is 11. This is the latest start time for project F. This is the earliest start time and the latest start time for project F. It is 11. Now project F is linking to activity F is linking to two activities here, which is D and E. So the latest start time for activity F is going to be the latest finish time for activity D. So when we are calculating the backwards pass, the earliest or the latest start time of an activity becomes the latest finish time for another activity, as long as the backwards pass is concerned. And so this LF minus D will give us LS. And so LF, which is the latest finish time for project F, minus its duration being 5 weeks, gives us 11 weeks here. So quickly we put 11 weeks here. Then 11 minus 5 is going to give us 6. This same activity F has activity E as predictor. And so we are also going to bring the same 11 here. 11 minus 2 is going to give us 9. Now we have two activities, which is D and then E. So for E, E's latest start time is 9, and then D's latest start time is 6. but project B is linked to project E and project D. In this case, talking about backwards pass, it is the smallest value of the linking activities that we have to use. Mind you, when we're going forward, we're using the highest values. And so in this case of E and D, we would have used the 9. But this is backwards pass. And so we are going to use the 6 of activity D. So it is very simple. You put 6 here. 6 minus 4, you have 2. Then activity C is linked to activity D. So you have 6 here. So 6 minus 3 is going to be 3. Now activity A is also linked to activity B and activity C. And with the same principle, when we are coming back, we are going to use the smallest value. Now the latest start time for activity B is 2. And then the latest start time for activity C is 3. And so if we are using the smallest value, then we are going to use 2. 2 minus 2 is 0. So we have actually calculated, as per this diagram, we have calculated forward pass, which gave us 16, right? Which gave us 16. Now we are going to work on our slack. We are going to work on our slack. We are going to work on our slack. And I told you slack is equal to LS minus ES or LF minus EF. And I told you the slack is simply the time an activity of a project can be delayed such that it would not cause harm to the entire project. Or yes, it will not cause harm to the entire project duration. And so for any of these activities, whichever one that has a slack of 0 is termed as a critical activity, which means it is an activity that we don't need to waste time on. It is an activity that we can't put aside. It is an activity that we can't hold on for anything. And so let's start calculating our slack. This is our LS, ES, and then LS. This is our LF and then EF. So this minus this is 0, this minus this is 0. Let's come to D. 6 minus 6 is 0, 2 minus 2 is 0. Let's come to E. 11 minus 8 is 3. 9 minus 6 is 3. Let's come to C. 6 minus 5 is 1. 3 minus 2 is 1. Then we come to D. 11 minus 11 is 0. 6 minus 6 is 0. Let's come to F. 16, 0, 11 is 0. And so using our slack to calculate which activities are our critical activities, you could see that A had 0 slack. Where should I write this? So A, so our slack activities we have A being our slack activity. We have B as a slack activity. We have D as a slack activity. And we have F as our slack activity. And so on this path, A, B, D, and F becomes our critical path. A, B, D, F becomes our critical path. And then our critical activities are just A, B, activity D, and activity F. And these are what we combine to give us the 16 weeks of our project completion. This is what we combined earlier on to give us the 16 weeks of our project completion. And so that becomes the entire duration with which we would complete our project. And so this is the critical path method, or the arrow method, for scheduling projects or for project management scheduling. And so you first of all have to draw your network diagram. After drawing your network diagram, you apply this rule to draw another diagram which is going to help you identify your critical path or your critical activities, which is also going to help you find your forward paths and then your backwards paths.